So on this question, we want to use the substitution method or the elimination method to solve the following system. Our system is 2x minus 8y equals 4, and negative 5x plus 20y equals negative 10. Now the directions here give us the choice of the substitution method or the elimination method. So I like to think about the two methods in this way to make my choice. The first step in the substitution method is to solve for one of the variables. So you want to have x equals or y equals. Whereas with the elimination method, you're looking to have all of your terms lined up, all of your x's lined up, your y's lined up, and your constants lined up, and your equal sign lined up. So in this example, it's already in the state that's closer to the first step of the elimination method. So I'm going to choose the elimination method. You can still use the substitution method if you like that better. But if I'm going to use the elimination method, I've got my x's lined up, my y's, my equals, my constants, and I need to decide which variable I'm going to eliminate. You can eliminate either x or y, and I don't see any advantage to either one, so I'll just go with the x because it's written first. So if I want to eliminate x, I need to find the least common multiple between 2 and 5, and that's 10. So 10 is what I want these coefficients to be. I want one of them to be positive and one of them to be negative. So to get the 10, I'm going to multiply by 5. To get the 10, I'll multiply by 2. And I've already got one being negative and positive, so that's already covered. So my new system will be 10x minus 40y equals 20, and negative 10x plus 40y equals negative 20. So now I'm going to add the equations together, and just like we planned, the x's will zero out or eliminate. 10x minus 10x is 0x, or just 0. But what we didn't plan for is that the y's will also zero out. Negative 40y plus 40y is 0. So on the left-hand side, all we have left is 0. On the right-hand side, 20 minus 20 is 0. So whenever this happens, and what I mean by this is that all of the variables are gone. When you have no variables, that means that you have one of your special cases of systems of linear equations. And here's what I mean by special cases. You have your normal case where two lines intersect in a single point, and then you have these special cases where the two lines never intersect, and you have the case where the two lines are on top of each other and they have infinite intersections. So the normal case will just have one solution, and these special cases, if the two lines are parallel and never intersect, there's no solution. If the two lines are on top of each other, you have infinite solutions. So anytime you start to work out your problem and all of the variables eliminate or cancel out, you know you're going to have one of the special cases. Now which one? Which one you can figure out based on what's left. Here we have 0 equals 0, which is a true statement. Because we get a true statement, you're going to know you're in the infinite solution case. So these two lines are actually the same line. So how do we represent those answers, those solutions? It's not any ordered pair, it's only the ordered pairs that are on that line. So here's one way to do it. We call this set builder notation. We're going to say ordered pairs, and these are ordered pairs that are on this line. Now remember, you've just figured out that these two lines are right on top of each other, meaning that they're really the same line. So this set builder notation is saying all ordered pairs that are on this line. Now sometimes you're expected to write it as an ordered pair. If you're wanting to write it as an ordered pair, you've got to solve your equation for one of the variables. So I think in my math lab, sometimes it tells you which variable to solve for. It says write your answer in terms of x or write your answer in terms of y. I'll show you both. So if they want you to write your answer in terms of y, that means you need to solve for x. So I'm going to add 8y. That's 2x equals 8y plus 4. Divide by 2. And you get x equals 4y plus 2. So you're going to write your y, and your x is 4y plus 2. If they tell you to write it in terms of x, you need to solve for y. So you take 2x minus 8y equals 4, and let's solve for y. We subtract 2x. That's negative 8y equals negative 2x plus 4. Divide by negative 8. And we get y equals 1/4 x minus 1/2. And so you would write x and 1/4 x minus 1/2. So in both these ways, both these ordered pairs, you're saying all ordered pairs that fit this format. So let me zoom out so you can see all of our work here. In this example, we want to use the substitution method or the elimination method to solve the system. The system is y equals 5/4 x minus 9 and negative 15x plus 12y equals negative 108. And the directions here do give us the choice between the substitution or the elimination method. For the substitution method, it's faster if you have y equals or x equals. And for the elimination method, you're looking for all your terms to be lined up, especially your equal sign. So in this example, we do have the y equals, so I'm going to go with the substitution method. So I'm going to take this 5/4 x minus 9 and substitute it into the other equation. And that's going to give me negative 15x plus 12 times 5/4 x minus 9 equals negative 108. I will distribute this 12. That's negative 15x plus 12 times 5 fourths x minus 12 times 9 equals negative 108. So let's see. I know that 4 goes into 12 3 times. So we have negative 15x plus 3 times 5, 15x. And we have a 12 times 9 is a minus 108. Negative 15x plus 15x zeroes out. And once again, all of our variables cancel out. So we know that I'm in that special case, either no solution or infinite solution. So which one are we in? We've got to look at our final statement there and decide how we get, we've got to decide whether that statement is true or false. We've got negative 108 equals 108. That's a true statement. Okay, so I'm going to go back for a second and talk about how I simplified here. Okay, so I'll back up even further. So I started with the distributive property, and so that's how I got 12 times 5 fourths x. And then I thought it would be easier if I did the division before the multiplication. So I'm doing this division first. So if I do that division first, doing 12 divided by 4, which gives me the 3, and then 3 times the 5 gives me the 15. If you want to do it the longer way, you would do it like this. 12 times 5 fourths, 12 times 5, that would be 60 over 4, and 60 over 4 is 15. So either way is fine. Okay, so getting back to here, we've decided that last statement is a true statement. And because we have a true statement, I know this system has infinite solutions. And I can write it in set builder notation, all ordered pairs, such that y equals 5 fourths x minus 9. Or if my math lab tells you to write it as an ordered pair in terms of x, it would be x comma 5 fourths x minus 9. If they said in terms of y, we have to put in a little work. So I would probably take the second equation here and I would solve for x. Negative 15x plus 12y equals negative 108. I'm going to subtract 12y. Got negative 15x equals negative 12y minus 108. Divide by negative 15. And I get x equals, and 12 over 15 is going to reduce down to 4/5 y. And 108 divided by 15, I'm doing that in my calculator, that's 7.2, so let's reduce it instead. Let's see, 3 goes into both of those. 108 divided by 3 is 36, and 15 divided by 3 is 5. Okay, so we'll leave it like that. 4/5 y plus 36 over 5, comma y. That's 3 different ways you can write the answer. That's a 4/5 y plus 36/5, comma y. Thank you for checking out my videos. Have a great day.